Euclidean geometry is a mathematical system attributed to Alexandrian Greek mathematician Euclid, which he described in his textbook on geometry. The elements. Euclid's method consists in assuming a small set of intuitively appealing axioms and deducing many other propositions, theorems, from these. Although many of Euclid's results had been stated by earlier mathematicians, Euclid was the first to show how these propositions could fit into a comprehensive deductive and logical system. The elements begins with plane geometry, still taught in secondary school, high school, as the first axiomatic system and the first examples of formal proof. It goes on to the solid geometry of 3 dimensions. Much of the elements states results of what are now called algebra and number theory, explained in geometrical language for more than 2,000 years. The adjective Euclidean was unnecessary because no other sort of geometry had been conceived. Euclid's axioms seemed so intuitively obvious, with the possible exception of the parallel postulate, that any theorem proved from them was deemed true in an absolute, often metaphysical, sense. Today, however, many other self-consistent non-Euclidean geometries are known, the first ones having been discovered in the early 19th century. An implication of Albert Einstein's theory of general relativity is that physical space itself is not Euclidean, and Euclidean space is a good approximation for it only over short distances, relative to the strength of the gravitational field. Euclidean geometry is an example of synthetic geometry, in that it proceeds logically from axioms describing basic properties of geometric objects such as points and lines, to propositions about those objects, all without the use of coordinates to specify those objects. This is in contrast to analytic geometry, which uses coordinates to translate geometric propositions into algebraic formulas.